Hey everyone, Jay here, and welcome to Python lab number 5. We're going to explore a little bit about data types and how we can cast values to be the type that they are or a different type, and a little bit of rounding as well. All right, not too fancy. We're just going to get introduced to those things. But if you'll see right over here, I actually have to look the other way. So it's over here on your screen, but it's over here to me. I have the instructions that we're going to go over. We're going to create our standard header at the beginning of the file. We're going to create a couple of variables with values of 1 and a 1 that's a floating point variable. It's just 0.1, 2, 3, 4, 5, 6, 7, 8, 9. I won't say that again. You can rewind it. And then we're going to add those numbers in a couple of different ways to see what their values come out to be, and then we'll output those values, and we'll also output the data type that results from modifying and adding those values. And I've got a couple of links in here to W3 Schools that will show you further reading on casting. Casting is when we take a variable and we cast it to a specific data type. It may already be that type, but it may be a different type, and the casting function will make its best effort to try and take the variable you've given it and put it into the type that you have cast it to. Different languages have a little bit more features to this or less features to this, depending on what the language is. Some languages will let you cast the word of a number into that number. Some won't, some will. You'll have to figure out which ones those are, and definitely don't plan on using it unless you know it's available. Let's get after it. See, this is the screen you want to see. All right, I have written my code already this time. Very awesome. All right, let me put a couple of lines in here so that I can scroll a bit. All right, so up at the top, we have our standard header for all of our assignments so far. We have the Python shebang, which tells Python that we're using Python 3 when it runs. If the computer doesn't have Python 3, let's say it only has Python 2, it will see this and it will go, hey, we should probably not run this program because it's made for Python 3. Right? Alternatively, if you make a program specifically for Python 2, you put Python 2 up there in the shebang, and then if the computer doesn't have Python 2, like mine, it won't run it. Right? Then I have my standard comment that tells you what this is going to be, but you already know that. But you came for the code. Let's have a look at that. So I have a first and a second variable. Now you'll see from the last lab, my variables were named a little bit differently. They were called myInt and myFloat. Now I'm calling it var first and var second. I don't need to use this word var. Okay, that's definitely not a requirement. I'm just doing it for this assignment as an explanatory. Okay, so what I like to use is called what is this called? Snake case, for example. There's different ways of writing your variables. There's a name for each one, right? So I tend to like to use the underscore in between the words. It's easy for me to read. It's easy for me to clearly see that it's a variable. But there are some industry standards amongst different languages. So whichever one you are using, make sure you use the naming convention that is correct for the language and the environment that you are using. Today, we'll be using this naming convention. So here's my variables. First one, it is an integer. I have not told it it's an integer. I haven't said, hey Python, this is an integer. I've just given it an actual integer value, and Python knows that's an integer. It will save it as an integer. Next one is a floating point value. It's not going to be saved as an integer. Wouldn't fit if you tried. And so it's going to be a floating point value. Okay, it's just a long decimal. I made it long on purpose because we're going to round it later and we're going to see what it looks like when you round it. All right, I guarantee you it's going to be accurate, but not the best. So then I'm just adding these numbers. So the first one I'm adding, and I'm saying the second one is going to be an integer. The second one is not an integer, but I'm forcing it to be an integer and then adding it to the first one. So when we run it, you'll get to see, what does that equal? What do you think? The second value, if I force it to be an integer, think about that and you'll see later what it's going to be. What value do you think it's going to be? It's likely it's going to be either a 0 or a 1, right? Because it's 0 point something, right? Is it going to round it? Is it going to just cut it off? What's it going to do? We'll find out. Stay tuned. Next one, I took my integer here and cast it as a float. That's not actually going to do that much. It's really going to change it from 1 to 1.0, and then it's going to add it to the second one. I'm not going to get any errors or anything. I'm just kind of wasting a little bit of computer time because I didn't need to do that. But now you know you can do it if you ever want to do it in the future. And then my third one here, can you see my mouse? You can see my mouse. All right, in the third one here, I'm rounding the second variable, this one, to 4 digits. I specifically pick 4 digits because that is the cutoff point to where the rounding stops going down and starts rounding up. You know how rounding works, right? You remember that from elementary school, perhaps? If it's 5 or more, you round up, and if it's 4 or less, you round down. Well, 4 digits is where that point is. Okay, so I want you to see what that looks like. Then after that, we're going to print. That means we're going to output to the screen what is the data type of the first sum, followed by the value of the first sum, and then what is the data type of the second one, followed by the value of the second variable. And you'll notice that my syntax here in the printing, the way that I've written it specifically is I have print function. Here's my parentheses for the print function. And I've given it actually 2 arguments separated by a comma. That's generally the way we call functions, and we'll call lots and lots of functions as time goes on. But I've given it this value to print, and the value is going to be the result of calling this type function, and it's going to give me a value to print. You'll see what that value is. Then I've given it a next value to print, which is going to print the actual value stored in the variable var sum1. And so I've done this for each of these. Without further ado, let's press the run button, and then I'll move my screen so you can see what it output. All right, so remember we printed sum1, which is this one, sum number 1. We didn't print sum1. We printed sum number 1, which was the integer, the var first, plus the var second, but the var second was cast as an integer. And so 1 plus the integer result of 0.123456789 is equal to 1, because when you cast a float, it's going to round all the way up to that whole number. Or is it rounding? We don't know. Is it just cutting off those numbers? We'll have to run again and test. We'll change that number to something else and we'll test what it is. And then what I get in the next one, I added them, but I made sure they were both floats. Okay, so no surprise there. It just really just added them. No problem there. And then the next one I added them, but I rounded that float at 4 digits. Okay, you'll see that it's 1, 2, 3, 5. Because I rounded at 4 digits, so after the decimal point, it kept those, but it rounded up because the next digit, a 5, causes you to round up. So that was pretty cool. Let's have a look and see what happens if we change this number here. Let's just, for argument's sake, let's just put a 5 there and rerun it with, we want to look at this one. I want to see, is it really rounding or is it just cutting off that number? Because it could just cut off the decimal places, right? And then it would just always round down every time. Mathematically, it'd be much easier, but let's see what it's doing. And let's actually show that to you. And it is still 1. All right, so even though I put the 5 in there, let's try it again with a 0.9. Let's really be sure about this. All right, let's do 0.9. So if I take 0.9, turn that into an integer, if it was rounding, it would absolutely give me a 1, and 1 plus 1 is 2. So I run this, and then I'll get you the output. Just you waiting. There it is. All right. It just truncated. It just cut off all those digits when I turned it into an integer. Okay. So it's a good thing I showed you how to round, because this ain't it, right? Just turning it into an integer is not rounding. So if you want to round, you will have to use the round function, right? You could round. Let's try and round to 0 digits after the decimal place. Can we do that? Can we round to 0 and run and show you the output? All right, we can round to 0, right? Now, if I round to 0, it's still a floating point, okay? So if you want to turn your floating point into an integer, but you also want to round it, you're going to have to do both of those things. You're going to have to round it and then turn it into an integer in that order, all right? So keep that in your mind, in your brain housing group, okay? So let's have a look at our code. That's the part you want, right? You came here for the code. Okay, so this is lab number 5. We're checking out some data types and a little bit of casting data types and a little bit of rounding, which is kind of also important, as we saw, when you're casting a float to an integer. It's not going to round unless you specifically tell it to round, right? So that's it for this video. Thanks for watching. See you next time.